Hello, I'm Robert Sunderhaft, and this is Cameron Erdman, and we are Team PomerenePools, and this is our AEP Wind Turbine Analytics project. So the problem, well, energy is very important to the world, and turbines play a big part in creating energy for us, so it's crucial that they stay up and running around the clock. So first thing to do to make sure our project works is the data cleaning. So first thing we did was we separated state and fault feature into 9 separate Boolean columns, so we can use these as labels to train on in our machine learning algorithms. Next, we dropped the rows that were bad, so tag not found, bad, and calc failed values were dropped, and then we turned all the categorical values into numeric values to run them on our models. And lastly, we standardized the values by mean. So one of the first things we did was we created a dashboard of visualizations. This is a rough prototype of a few of the features we wanted to include. So we included things like wind direction, wind speed, power, which was basically the percentage of power you currently have versus the best power that they could have. As you can see, station B has no power, so it's probably down. And at the bottom, we have the production-based available graph, and you can zoom into any one of them.
So when we wanted to build our model, we were looking to try to predict the status of the turbines given the variety of data we had. So we trained on a variety of models, and we saw similar performance on most of our models. And such, we went with logistic regression for simplicity's sake and explainability. We then utilized recursive feature elimination to determine the most important features to our model. When predicting the status of turbines, we can see that we have very accurate model, almost too accurate, but we checked. We standardized our data. We checked to make sure the fill levels were fine, and we checked that our data was balanced, so there was no issues there. We can also further prove this when we look at the most significant variables, as well as what happens when we drop them. We see about a 5 to 10% decrease pretty quickly just by dropping the most 5 significant features. And so that kind of helps to prove the point that our model there's no error going on, and that we just had created an accurate model. And so we also then went on to predict the faulty turbines. And so we trained our model on a collection of all 9 turbines. And then we subsetted them back into their original turbines and then predicted on those turbines. And so we can see that turbine A has an uptime of about 58% according to our prediction. And so we can label faulty turbines such as turbine A, B, D, and so on.
So for future steps, we want to build out the dashboard and add theming and formatting, and also we want to add early predictions. So in the model, we'll have like a number that can predict the status of each turbine. Next, we want to create Kubernetes pipeline to have the data to scripts the dashboard, so it's nice and easy. And last, we want to deepen the air model. So we want to build more robust air metrics that we can put on the dashboard. Thank you so much, AEP. We really enjoyed doing this project. Thank you again for the hackathon.